Hello friends, and welcome back to my YouTube channel. I'm really excited to have you here today as we dive into an essential topic in the world of electrical engineering. We're setting off on a journey to explore switchgear, the heart of protection systems in modern power networks. The key feature of modern world is its heavy dependency on electrical energy. As electricity generation increases to meet up the rising demand, the cost of maintaining this supply also grows. This tells the crucial role electricity plays in our daily lives. To ensure a stable and reliable energy flow, power systems must be protected from faults and damage. Because of this, switchgear is invited to play a critical role in electrical power systems by managing, protecting, and isolating electrical equipment. They are essential components used to control the flow of electricity within a power network, ensuring both operational flexibility and safety. Switchgear is designed to de-energize equipment for maintenance and to clear faults downstream, thus preventing damage and minimizing outages. Their roles in power systems cannot be overemphasized. Now, let's dive into the world of switchgear and explore its fundamentals, importance, and role in protecting the power systems that drive our daily lives. Welcome back. If you are new to my YouTube channel, welcome. Please, don't forget to support the channel by hitting that like button and subscribing to the channel. It really helps us grow and keep bringing you awesome content. Thank you for your support. Now, let's dive straight into today's exciting topic. Switchgear comprises devices used for switching and protecting electrical circuits. This includes switches, fuses, circuit breakers, and relays. In normal operating conditions, it enables safe switching operations of various power system components. In the event of faults such as short circuit, surge current flows through the system, risking damage and disrupting service. Switchgear detects such faults and isolates the affected section, thereby protecting the rest of the system and ensuring steady supply. This is a typical example of what switchgear can do. The primary function of switchgear is to switch and interrupt electrical currents under both normal and abnormal operating conditions. As we have explored what switchgear is, let us analyze some features that make up a switchgear system. These significant characteristics help them to stand out as a protective system. These essential features of switchgear include the following. 1. Total reliability. As interconnection continues to grow and the capacity of generating stations increases, the demand for dependable switchgear has become crucial. This is understandable, as switchgear is integrated into the power system to enhance its reliability. When a fault occurs in any part of the power system, the switchgear must function to disconnect the damaged section from the rest of the circuit. 2. Unquestionable smartness. When a fault happens in any part of the power system, the switchgear must be capable of distinguishing between the faulty section and the healthy sections. It disconnects the faulty section from the system without impacting the healthy sections, ensuring an uninterrupted supply. 3. Rapid operation. When a fault occurs in any part of the power system, the switchgear must respond swiftly to prevent damage to generators, transformers, and other equipment due to short-circuit currents. If the fault is not cleared quickly by the switchgear, it could spread to healthy areas, potentially causing a complete system shutdown. 4. Manual control option. A switchgear should have a provision for manual control. In the event of failure in the electrical or electronic control system, necessary operations can be performed manually. 5. Instrument provision. There must be space for any instruments that may be needed. These could include ammeter or voltmeter on the unit itself, or the required current and voltage transformers for connection to the main switchboard or a separate instrument panel. These inbuilt behaviors of gear switch make them unique and excellent devices for interrupting faults. As we have explored those behaviors, let us now see protective systems that make up of switchgear. A brief overview of these devices is provided below, but more detailed information will be found in my next class. These protective systems include 1. Switches. A switch is a device used to open or close an electrical circuit. It can operate under both full load and no load conditions, but it is not capable of interrupting fault currents. When the switch contacts are opened, an arc forms in the air between the contacts, especially in high voltage circuits with large current capacities. Switches are categorized into two types: air switches, where contacts are opened in the air, and oil switches, where the contacts are opened in oil. 2. Fuses. A fuse is a small wire or thin metal strip that melts when an excessive current passes through it for a certain period. It is connected in series with the circuit it protects. During normal operation, the fuse remains below its melting temperature and carries the load current without any issues. However, in the event of a short circuit or overload, the current exceeds the fuse's rated limit, causing its temperature to rise above its melting point and blow the fuse. This action breaks the circuit, preventing damage to equipment and machinery. 3. Circuit breakers. A circuit breaker is a device capable of opening or closing an electrical circuit under any condition, whether no load, full load, or fault situations. It is designed to be manually or remotely operated during normal situations, and to automatically operate in the case of faults. 4. Relays. A relay is a device that detects faults in an electrical system and sends a signal to a circuit breaker to interrupt the circuit. The relay typically consists of two main components: current transformer for measuring current in the system, and tripping circuit for sending a signal to the circuit breaker to trip and interrupt the circuit when a fault is detected. Since we have seen some basic protective systems that make up gear switch, let now us examine conditions and factors that determine where to place gear switch, whether inside or outside. It is important to install switchgear in power stations and substations in a way that ensures the safety of personnel during both operation and maintenance. Additionally, the setup should limit the impact of any faults to a specific section of the system. Based on the voltage level involved, switchgear is generally divided into two categories: indoor and outdoor types. For outdoor type, when the voltage exceeds 66 kV, switchgear is usually installed outdoors. This is because at such high voltages, the required spacing between conductors and the physical space needed for equipment like switches, circuit breakers, and transformers becomes so large that indoor installation is not safe. For indoor type, for voltage levels below 66 kV, switchgear is usually installed indoors as it is more cost-effective. Indoor switchgear is usually of the metal-clad variety, where all live components are fully enclosed within a grounded metal enclosure. This design aims to ensure that any electrical fault is contained and limited to its point of origin, enhancing safety and system reliability. Now that we have a solid understanding of switchgear, let's explore the key factors to consider when selecting and recommending switchgear for power system protection. When selecting switchgear, several key factors need to be considered to ensure it meets the requirements of the power system. These factors include: 1. Reliability. The switchgear must be highly reliable to ensure continuous operation of the power system. It should be capable of isolating faults and preventing the spread of faults to other parts of the system, ensuring system stability and minimizing downtime. 2. Smartness. The switchgear should be able to distinguish between faulted and healthy sections of the system. It should isolate only the faulty part of the circuit without affecting the rest of the system, ensuring that the supply to unaffected areas continues uninterrupted. 3. Speed of operation. The switchgear must operate quickly when a fault occurs to prevent damage to expensive equipment, like transformers, generators, and other electrical components. Fast operation helps minimize the impact of short-circuit currents and prevents further damage to the system. 4. Manual control capability. In case of failure of the electrical or electronic control system, the switchgear should allow for manual operation to perform necessary actions and maintain control over the system. 5. Instrument provision. The switchgear should have provisions for monitoring instruments such as ammeter, voltmeter, and current and voltage transformers. These instruments help in measuring system parameters and are vital for monitoring the health and performance of the system. 6. Current and voltage ratings. The switchgear must be rated for the appropriate current and voltage levels of the system it is intended to protect. This includes considering the maximum fault current that the switchgear will need to interrupt safely. 7. Environmental conditions. The environmental conditions where the switchgear will be installed should be considered. This includes factors like temperature, humidity, and exposure to corrosive elements, which might affect the performance and longevity of the switchgear. 8. Maintenance and accessibility. The switchgear should be easy to maintain and service. Components should be accessible for routine inspections, testing, and repairs to ensure reliability over time. 9. Cost and budget. The cost of the switchgear is an important consideration. While reliability and functionality are the top priorities, the switchgear should also fit within the budget constraints of the project without compromising on essential features. 10. Compliance with standards. The switchgear should meet industry standards and regulations for safety, performance, and interoperability with other equipment in the power system. In conclusion, switchgear plays a vital role in electrical power systems, enabling control, regulation, and protection of electrical circuits and equipment. By understanding the different types of switchgear, including circuit breakers and relays, engineers can design and operate reliable power systems that minimize downtime and ensure safety. Effective switchgear selection and application are crucial for maintaining system stability and preventing damage from faults. That's a wrap for today's class. If you like this video, please like and subscribe to the channel for upcoming videos. Thank you for watching and bye for now.